Okay, a couple ways that we can verify that two functions that we're given are actually inverses of each other. One is to just graph them both. We know that if we have inverse functions, they should be a reflection over the line y equals x, that diagonal, fold on the diagonal, and the pictures line up. But sometimes that graph can be either really messy or it looks like maybe it's a little bit off and we want to be 100% sure. So the algebraic way of showing that we have inverses is to show that they really undo each other, and that's by using function composition. So we need to show that f of f inverse of x is the same as f inverse of f of x, which is x. In other words, I take my x, remember how composition works, I take my x, I plug it into f inverse, get an answer, take the answer, plug it into f, and I get back what I started with, my original x. All right, let's take a look at how that would work. And I purposely kind of picked one that had some fractions in it so that we can review some algebra. I've got f of x equals this 2/5 x plus 1, and f inverse of x is equal to this quantity 5x minus 5 over 2. Okay, so f of f inverse of x would be f of whatever f inverse is, so come up here and grab f inverse, put that there. Okay, so f of something means you take this something and it replaces, erase that one, replace this x with all this stuff here, and it looks like 2/5 times that big quantity plus 1. Well, the good news is the 2's cancel, right? Because we're multiplying, we can reduce that. And then I have the 5x minus 5 over 5. So I divide each of those, and that gives me x minus 1. And scroll down just a little bit further. 1's cancel, and yes, I have just x. But I have to verify that it works the same way the other direction. Okay, so f inverse of f of x is going to be f inverse of whatever f of x was, and that was that 2/5 x plus 1. Okay, so now I have to, let me scroll up so you can see that a little bit better. I need to take all of this stuff and replace this x up here by the 5 with this expression. So it's 5 times that whole quantity minus 5, because that's the rest of this up here, all over 2. So I'm going to distribute the 5, and when I distribute the 5 times the 2/5, of course it cancels the 5, and I get just my 2x. Plus 5 minus 5, well, those are going to cancel. Then I get 2x over 2, and that simplifies to an x. So we just verified that what we really did have were inverses of one another.